Hello everyone, welcome back to my YouTube channel. Myself Kirtana HR, currently pursuing in first year BE in the Department of Computer Science and Engineering at Sri Venkateshwara College of Engineering. Today's subject Applied Physics and the topic Creation of Animated Characters by the Application of Physics. Today I am going to explain about Introduction, Types of Animation, Applications of Animation, Basic Principles in Animation, and Steps for Creating Realistic Physics Simulation in 3D Creation. Introduction. Creating animated characters with the application of physics involves simulating characteristic movements and interactions based on the principles of physics. This process enhances the believability and naturalness of character animations. Physics-based animation typically involves rigging and skeleton setup. Being by creating a skeleton for the character, defining joints and bones, attach a physics-based rig to simulate realistic skeletal movements. Mass and inertia. Assign mass and inertia properties to different parts to character's body. Heavier parts will respond differently to forces compared to lighter ones. Joint constraints. Define joint constraint to limit the range of motion for joints mimicking real-world anatomical constraints. Gravity and external forces. Apply gravitational forces to make characters move realistically in a virtual environment. Introduce external forces such as wind or friction to affect character motion. Collision detection and response. Implement collision detection to ensure characters interact with the environment and other objects. Define responses to collision like bouncing off surfaces or alternating movement trajectories. Ragdoll physics. Incorporate ragdoll physics for characters when they are not actively controlled. This allows for more natural reactions to unexpected interactions of force. Inverse kinematics. Use inverse kinematics to calculate joint movements based on the desired position of the character's end efforts like hands or feet. Simulation techniques. Employ simulation techniques like particle system, efforts such as hair, cloth or fluid dynamics. Utilize physics solvers to ensure accurate and stable simulation. Animation controllers. Develop animation controllers that blend physics-based animations with artist-created animations for precise control. Iterative refinement. Continuously refine the simulation parameters based on the visual feedback, adjusting mass, damping, and other factors to achieve desired results. The next is types of animation. In animation, there is 5 types of animation that are traditional animation, computer generating animation, stop motion animation, 2D vector animation, and the last is motion capture. Now let us see applications of animations. The first one is entertainment. Movies and TV shows. Animation is a fundamental part of both the traditional and computer generated films as well as animated series. Video games, animation enhance the gaming experience by bringing characters and environments to life. The next is education. E-learning. Animation makes educational content more engaging and helps in simplifying complex concepts. Amazing. Commercials. Animated message advertisements can be eye-catching and convey messages creatively. Digital marketing. Animated content is used in online campaigns, social media. Medical illustration. Animations are employed to illustrate medical procedures, anatomy and biological process for educational and instructional process. Pictorial visualization. Message animated walkthroughs and flyovers help architects and designers present their concepts and designs more effectively. Simulation and training. Industries such as aviation, military, and healthcare use animation for simulating scenarios and training personnel. Virtual reality and augmented reality. Animation enhance immersive experiences in VR and AR message applications from gaming to virtual tours. Web design and user interface. Animated elements in web design and UI or UX enhance user interaction and create a dynamic user experiences. Develop animation controllers that blend physics-based animations with artist-created animations for precise control. Iterative refinement. Continuously refine the simulation parameters based on the visual message feedback, adjusting mask, damping, and other factors to achieve desired results. Let us see principles of animated videos. Time, spacing and scale, law of inertia, weight gain and loss, action and reaction, momentum and forces, and center of gravity. These are the principles of animated videos. Now let us discuss briefly about these principles of animated videos. Law of inertia. Law of inertia is the resistance of any physical object to any changes like starting or stopping a motion or changing direction. Time spacing and traveling. Spacing is the distance an element travels between two frames of an animation. Timing is used in animation to produce motion that adheres to physics rules and adds interest. Weight gain and loss. When a character is moving, its effective weight can be constantly changing. Action reaction. The principle of action reaction, also known as Newton's third law. When a character interacts with a character direct with an object, both are affected. Forces. The principle of force and momentum says that an unbalanced force will change an object's momentum. The bigger the force, the quicker the momentum changes. For moving characters, this change in momentum could result in increasing or decreasing a character's speed, or it could be a change in direction. Center of gravity. The center of gravity is the average location of an object's weight. The center of gravity is important for various reasons. The path of action of a moving character, the point that we are most interested in tracking, is the center of gravity. Steps for creating realistic physics simulation in 3D animation. The first one is choose the right software. The first step to creating realistic physics simulations in 3D animation is to choose the right software for your needs. There are many options available. The second one is set the parameters once you have chosen your software. You need to set the parameters for your simulation. These are the values that determine how your simulation behaves and interacts with other objects and forces in your sense. Some of the common parameters you need to add: mass, friction, gravity and collision. The third one is optimize the performance. Creating realistic physics simulations in 3D animation can be very computationally intensive and time consuming, especially if you have complex or large scale simulations. Therefore, you need to optimize the performance of your simulations to reduce the render time and the memory usage. Is add details and variations. One of the challenges of creating realistic physics simulations in 3D animation is to avoid making them look too uniform or artificial. To add more realism and interest to your simulation, you need to add details and variations that reflect the natural diversity and imperfection of the physical world. The fifth one is review and refine. The final step to creating realistic physics simulations in 3D animation is to review and refine your simulation until you are satisfied with the result.